Now go. All right, number 4, final answer, factorial. Number 12, you were plugging and chugging to get your first 5 terms. There we go. First term, second term, third term, fourth term, fifth term. Hopefully mental math went all right in PEMDAS. We're doing things legally. Did the air just turn on? So sorry. That's rough. Okay, can I keep going? Cool. Number 22, same dealio, plug and chug. Practicing our mental math. The sequence would be 1/2, -1/5, 1/10, -1/17, 1/26. Question. Can sequences alternate signs? Yes. They're either all positive, or they're all negative, or they alternate. Is it working now? Yeah. Oh, man, I don't know what happened. Now we'll see if he's happy again. Number 60. You guys were now plugging in with factorials and seeing if you did all right. Now the nice thing is you weren't simplifying factorials. You just had to plug in and say 0 factorial is 1 and then simplify the rest and get 1. 1 factorial is 1, 2 factorial is 2, 3 factorial is 6, 4 factorial is 24, 5 factorial is 120, etc. Oh, you only went to 4. Question, why only go to 4 if they asked for the first 5 terms? Because 0 is the first one. Good. You guys notice that? So if 0 is the first one, you're going to go to seemingly 1 less than you should, but it's not because 0 counts as the first, second, third, fourth. So sorry, 1 1/3, 2 fifths, 6 sevenths, 8 thirds. Then, is there one more? There are 2 more. Number 64 was like those ones we were doing in class together. 12 factorial, 12, 9, sorry, 12, 9, 12, 11, 10, 9, 8, and then the 7 factorial. Oh, I would have canceled out the 8. Oh, they did. Okay. It's just weird because it's not crossing the 8. They canceled out the 8 factorials because they both shared the 8 factorials. Then you had 12, 11, 10, 9, and 4, 3, 2, 1. I would have canceled the 2 and the 4. That doesn't work. 3. Oh, the 3 and the 4. The 3 and the 4 could cancel with the 12.
They did.
Oh, I didn't see what they were doing. Okay, so 2 could go with 10, 3 and 4 could go with 12, and then you end up with, nice, just 9 times 11 times 5. And then last but not least, you were practicing your summation notation. What's this Greek letter again? Sigma, good. Sigma notation symbolizes, signifies, shows a sum. So you start at 0, plug in 1 and 2 and 3, and stop at 4. Solve, 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 you get 11. What's a fast mental math way of doing this without plugging it into your calculator? Speaking of which, pause, think about it for just like 10 seconds. Let me get a calculator open. Let me come back. What's a good mental math way of solving that? Multiply by negative, like actually do the powers? Yeah, I could actually do it.
Find 1. You know that -2 to any power, or sorry, anything to the 0 power is just 1, so you can think about things separately, so plus 1. I guess it's not really a great way. I was going to say you could factor out, like you could do some grouping, you could like factor out a -2 and factor out -2 cubed, you could do some stuff like that, but you probably could, since it is -2 to a power, you could probably solve that one. I was trying to think of mental math tricks to do that one. I probably would have just raised it to powers though. Why am I getting out my calculator though? It does have a button. New calculators do. Old ones sadly do not. The ones with yellow buttons, I'm so sorry. The programming, it can basically do everything that the new ones can, just not quite as nicely. And this is, I think, the one feature where it really lacks. And it's only because it was an old programming language. The new programming language can do a lot more. What did you guys find if you went looking in your calculators about summation? Don't stop.
Second math?
Not second math.
And then I think numbers or something.
You guys see the little sigma? That's a nice one, huh? Isn't that cool? Now, do you literally have to go find a J? No. What could you use?
X.
Yeah, x is the fast variable. Don't even have to do alpha. Just do x, and then we can go ahead and do from 0 to 4. Now, what would you put in your formula, though? You would do your -2, but to what power? Use whatever variable you put in. Does that make sense? If you use j, use j. If you use a, use a. If you use k, use k. Just make sure you use the same variable. Ready, set, and go. Why didn't I show you that on Friday? I don't think I did I?
Because it would have made us lazy slackers.
Yeah, A, lazy slackers, and B, any non-calculator. You guys are just like talking all over the place. It's a Monday, you're supposed to be tired and just like, Because the air's on, you're too woken up. But anyway, if you can use your calculator, this is cool. If you have to do it by hand and be a non-calculator portion, I needed you to know how to do it. Ashley, go ahead.
Where is it under math?
Oh, go math, and then as long as you have a newer, updated calculator, just go up. Just go fast to the bottom of the list, and it's number 0. Yeah. People with the yellow button, I'm so sorry. There's not a good way. There's not a good way to do it on the old one. Not a straightforward way. We have to go into sequence mode and do these sum things. And it's easier, I promise you, people with old calculators, just to plug it in and then type it all in once. It's easier just to do it that way. I think that's the biggest shortcoming or the biggest pitfall of the old calculator. Okay, ready, set, and we can't check 9-2 because we haven't done it, so let's go do it. Here we go. Let me see if my iPad is now working that the Wi-Fi got hooked up. Somehow it wasn't. Ah, there it is. Alright, here we go, notes open. If you guys notice, how long are we going to try and take on 9-2? 1 day, so let's get going. Woo! It's a chapel day?
Let's take 5 days.
Oh, you'd be so bored if we even tried to make it 5 days.
But yeah, and I could have time to catch up.
We will take 2 days on section 9.3, and we might revisit the idea of the Fibonacci sequence, which would be fun. But we don't have time today with chapel day.
Arithmetic.
Alright, here we go. If you guys remember, and you probably don't, I'm just trying to bookend something that I referenced earlier. Section 9.1 was an introduction to sequences and series. And we saw things like A sub n formulas, recursive formulas, sequences and series, what they are, how we denote them, etc., etc., etc. What they are and how we denote them, etc., etc. We were introducing them, but we weren't really talking about the special types of sequences and series. Not really. There is something that we'll come back to once we get to section 9.3, but long story short, in 9.2 and in 9.3, we're going to talk about 2 special types. In 9.2 and in 9.3, we'll talk about 2 special types. Now, once again, we did actually skip a page in our 9.1, if I can get there. We skipped a page in our 9.1 notes, but we'll get back to it when we introduce section 9.3 tomorrow. Don't stress too much about that. You might have had a homework question on it. But for right now, 9.2 and 9.3, we're going to zero in, zoom in on 2 special types. And I told you that in section 9.1, you wouldn't have to figure out that whole nth term formula thingamabob, because it was super complicated. But in 9.2 and in 9.3, you will have to, because every sequence that follows these special patterns which is not all-inclusive. There are some sequences that don't fit in 9.2 or 9.3. We would just say they're neither of the special types. Like the Fibonacci, it doesn't fit in 9.2 or 9.3 nicely. There are plenty of sequences that do not fit in 9.2 and in 9.3. But just as an introduction to this whole idea of sequences in series that technically you wouldn't pick up again after pre-calculus until calculus level 2, which is similar to calculus BC. Although BC technically covers AB and BC content, it's kind of the Calc 1 and Calc 2 class. So Calc 2 comes back to this idea of sequences in series and goes in a whole lot more depth. So we're just kind of scratching the surface. We're just kind of introducing. So 9.2, arithmetic sequences in series. 9.3, geometric sequences in series. Just the beginning, just an introduction to some special types. As you guys are writing, question, why does it make sense that there are subtractions in this yellow box because of a certain math term that's somewhere on this page? Difference. Whenever you see the word difference in math, you should think of subtraction. And what are they saying is true about all of these differences? Yeah, look at the English, and the English says they're common, right? Look at the math, and the math says they are equal. So what's special about an arithmetic sequence is that the differences between, wait a minute, what terms are they subtracting? Can you guys tell? Yeah, a second from a first, a third from a second. Aren't they subtracting consecutive terms? The latter minus the previous, or the prior? Former? That sounds better. The latter minus the former. So whenever you subtract a latter term, that just sounds awkward now. Whenever you subtract a term from its previous term, I shouldn't say that, a previous term from a current term, anyway. Whenever you subtract, the difference should be the same. However, that is not the pattern that we specifically see when we look at it. What we are going to see when we look at a sequence, the pattern that we're going to see, is not going to be subtraction. The pattern is how to go from one term to the next, and that is going to look like addition. When you do a sub 2 minus a sub 1, you'll find d. So to get from a sub 1 to a sub 2, you're going to add d. To go right to left, you subtract. To go left to right, you add. So, as we progress, as you look at a sequence, if it has the pattern of going from one term to the next recursively, if that pattern is adding a constant, adding the same number over and over and over and over again, then it is called an arithmetic sequence, and that common difference is what we call the D. Now, here's a quick question. If the pattern is adding, that's not the one I want. If the pattern is adding the same number over and over and over again, my question to you is, can this ever decrease? Can an arithmetic sequence ever decrease if you're adding the same number over and over and over again? What do you guys think? What's your gut say? You're adding and adding and adding and adding. Can it ever decrease? No. Your gut would say no, but just a few of you are like, wait. Yeah, it can. If you're adding a negative number, right? So, just a quick little note that we're going to add before moving on. We can make a quick note that D, there's a star up above. Let's use a different symbol. D, or the common difference, so if you guys see it going down, or I shouldn't say down per se, I should say going more negative, that means D must be negative. D can be negative or positive. So we don't describe the pattern as, oh, you're subtracting, or oh, you're adding, or oh, you're multiplying, or oh, you're dividing. We try to describe it in one sense like, ooh, you're adding a positive, or oh, you're adding a negative. And that's the way that we can think about adding a common difference, even if it's going more negative. That was just a quick little note. D can be negative or positive. And if D is negative, it'll look like subtraction. And technically, that's what subtraction is. You guys know that from algebra, right? Whenever you do 2 minus 3, isn't that the same thing as 2 plus a negative 3? Right? And how should that help? Some of you still make these mental mistakes, and that's okay. 2 minus 3, most of us can get to be what? Negative 1. But what if we say negative 3 minus 7? Some of us get confused. Is that 4? Negative 4? Is that 10? Is that negative 10? But if we look at this as negative 3 plus negative 7, shouldn't we know? Oops. No judgment. It's a Monday morning.
Judge.
I know.
Judge.
Because I was doing the
That's
answer.
the answer, yeah.
Negative 3 plus negative 7. This is the exact same thing, and most of our brains can better process this one What's -3 plus -7? -10. Easy. If only you were taught subtraction was addition of a negative way back when. Maybe you were and you just forgot. Alright, let's go find some arithmetic sequences. Ooh, let's not even find them. Let's determine whether or not they are. Oh, A's no fun. It's not even a sequence. Yet. Question, how do we make letter A a sequence? How do you make letter A a sequence? You don't? Oh, come on, you did it last homework. Yeah. Start with the first term, right? A sub 1, A sub 2, A sub 3, A sub 4. And if you guys like sequences going horizontally, you don't have to go that way. You could do A1, A2. We're trying to find a pattern, right? Okay. Good question. What would A1 be when you plugged in?
7.
Yep, plugging in 1, 4 plus 3 is 7. How about when you plug in 2?
11.
When you plug in 3?
15.
Okay, wait a minute. Anybody found the pattern yet? Exactly. So then what would the next term be? Got it. We can keep on going as long as we want recursively by jumpity jump jumping plus 4. Or we could plug into, remember when it says the nth term, doesn't that mean this is A sub n?
Yeah.
Make sure we know that vocab. I know guys, it's rough and it's cold. It's warm. Under event. I'm similar to some of you guys that are under event. Okay, so how could we say, or what could we prove? How could we prove this is a arithmetic sequence? Yeah. Arithmetic because D equals 4. Positive 4 because we see it going more positive as we add, right? Let's say it was 19, then 15, then 11, then 7. Does that make sense? D equals positive 4, so going up. Now, just a few of you might be able to say, hey, I think I can realize that from the formula without even plugging in. That's a hard thing to do. Just a few of you might realize as n increases, you're adding another multiple of 4, meaning another 4 is getting added in. So that's a little harder to see. For most of us, it's a lot easier just to go ahead and be like, whatever, I'm going to look at the sequence and then figure it out from there. Both ways work. Now, question. In letter B, they've given us some terms, and they've given us the nth term formula. Remember, whenever they say that nth term, that means this guy is A sub n, or vice versa. If they say A sub n, we know it's the nth term. Does this one work to be arithmetic?
No.
Now, is there a pattern?
Yeah.
Yeah. What would the pattern be? Let's see, plus 3, plus 5, plus 7. You guys see how I'm adding ons? But it's not the same number, first of all, right? And this nth term formula, if you check out n squared, as n goes from 1 to 2 to 3 to 4, I'm not adding just one number. So however you look at it, this is not. What do you say no? Is it arithmetic? No. Why? There's no common difference. There are differences that follow a pattern, but they're not common. There, just turn up. Now, just a quick hint, this is not geometric either. So it's technically neither. Potato, potato. It's neither of our special ones from 9 2 or 9 3. Has a formula, has a pattern, but not arithmetic or geometric. Okay. We're getting ready to think about how to find the nth term, and there are formulas that I just hid down below. As to any arithmetic sequence, how can you find the nth term formula? How can you find A sub n? There's a pattern, that's why we're going to be able to do this one. It's not going to be as hard as the ones in 9-1. If I even gave you any, I might have not. Did I give you any A sub n, find the formulas? Okay, one just to try. But my question, Caleb, I'm coming to you, don't worry. My question is, given that sequence that you see 2, negative 3, negative 8, negative 13, how could you jump to the 20th term? Go ahead, Caleb. Yes. What's one way that you could jump to the 20th term?
You find out what D equals and then multiply it by what term we want and then subtract or add it to the first term.
You find the formula and just plug it in.
Almost.
Find the formula.
It's not negative.
Okay, so we have two different ones. Nathan's like, hey, let's find the a sub n formula and just plug in 20. Okay, that's cool, but how do we find the a sub n formula?
Find D.
Ricky's saying find d and multiply it by 20 and add it to 2.
First term.
Negative 5 times 20 plus.
Oh, yeah.
Close. Wait. Jason, why negative 5?
Because that's the difference.
Good. I'm subtracting 5 every time, which means d is equal to, you can think of adding a negative 5, right?
Yeah.
And that works. So we can say that d is equal to negative 5. Now, Jason and Ricky are both trying to figure out how to put this together to find a sub 20. I agree with their idea that we do want to multiply negative 5 by something.
I say 19.
Why 19 and not 20?
Because
Because 2 is A1.
yeah. Percent.
You have to think about how many jumps. Kiddos, this is a sub 1, and I didn't take any jumps to get there, right? A sub 2, how many jumps did I take to get there? Just 1. A sub 3, how many jumps to get there? 2 altogether, right, from the first term? Because we're going from, if you guys notice, we're going from the first term. So then a sub 4, how many jumps to get there? 3 jumps, right? So if you think about it, in order to get to a certain term from the first term, there's going to be 1 fewer jump than the n of its term. Think of it with your fingers, right? How do you jump from 1 to 5? Do you take 5 jumps? No. How many spaces you got? You only have 4 spaces, right? So you're going to jump 4 times in order to get from 1 to 5. Same thing here. To get from 1 to 20, we're going to jump 19 times. Now, if we were to start at a sub 0, then we would have 20 jumps. But we're starting at a sub 1. So long story short, 1 fewer jump of negative 5. We can get there quickly. The other way would have been like, hey, let's subtract 5 to get to the 5th, subtract 5 to get to the 6th, subtract 5 to get to the 7th, and the 8th, and the 9th, and the 10th, and we could have just done it in our calculator, right? Does it sound nicer just to multiply by 19?
Yeah.
I think so too. Who's already found it for us? Somebody, come on.
Negative 93, I think.
93? You guys all agree?
Yeah.
Cool, that's what I think I heard. Yeah.
Where did the 2 come from?
Oh, because the 2, we had to start from somewhere. So we started from 2, and we said, okay, from our initial, or from our first term, how many jumps of that negative 5 would we have to do to be able to get to a sub 20? Does that make sense? So we're starting at the beginning. We have to start at 2. Figure out our pattern, subtracting 5 or adding a negative 5, and then say, okay, how many times would I have to subtract 5? The answer is 19. Now, guys, does that then make sense with the formula that we now have below? For any arithmetic sequence, any sequence with a D, a common difference. For any arithmetic sequence, let me help you guys in the back. Couldn't we just say to get to any nth term, we start at the first and do n minus 1 jumps times the difference? Or n minus 1 jumps of the difference? If you're a highlighting, starring kind of person, I would definitely highlight star this formula. 9-2 and 9-3 both have quite a few formulas for us to hold on to. So arithmetic sequence, formula for the nth term, how to jump once we find the pattern of a common difference. Just think of it this way, repeated addition is multiplication, right? 5 plus 5 plus 5 is the same thing as 3 times 5. 5 plus 5 plus 5 plus 5. 4 times 5, right? Adding 5 to itself 100 times, 100 times 5. So we're just saying, sweet, instead of having to do all that plus thing, we're just going to multiply d by n minus 1 jumps. So real quick, just in case you need a reminder, a sub 1 is just our first term. That was like the 2, David, in the example above. and D is our common difference. You guys should only see one other variable, which is the n, and then the n is going to be the number of the term we're finding. The number of the term that we're finding as identified by a sub n. So if it's a sub 20, n is 20, a sub 100, n is 100, etc., etc. So this next example should be fairly straightforward with that formula. How could we then do the following? They're not even asking for a term. They're asking for a formula. Plug it in, plug it in. How'd you know 2 plus? Got it. So that's our a sub 1. And 2 plus what? And how'd you know 3? Now, this formula is totally right. Nicely done. But do you think if we were given a formula, they would write it like that? Probably not. Because can't you distribute and combine some like terms? So here's the idea of a common, I shouldn't say common difference, an nth term formula for an arithmetic sequence. The dealio is that is the basic form that we plug into. However, it could simplify to look something like that one that we had a little second ago, which was, I think, 4n plus 3. If we just do a little bit of distribution. 2 minus 3, there are like terms, right? Negative 1 plus 3n, or to be honest, it probably look a lot nicer if we just did 3n minus 1. So even though this is right according to the formula, we wouldn't necessarily be given that in the beginning. And that's why I think it's kind of easier if you're given an nth term to go ahead and just expand it and say, hey, who is the sequence? Let's see if we can figure out what he looks like and then see if we can find that common difference. Because these formulas might always look a little bit different, but what's the same is that for an arithmetic, you do have multiplication by n. You do have multiplication by n, and n does not appear anywhere else in the formula. You have a constant multiplied by n, and n does not appear anywhere else in the formula. Yeah, A1 has to be 2. So remember, this final one is just the simplified form, but we did still plug into our formula from the page before right there with our a sub 1, our n minus 1 times our common difference. Then we just simplified to make it look pretty like the bottom. Okay, let's keep going. Sequences. Let's do one more example. What if they don't tell you explicitly, hey, the first term is and the common difference is? What if they don't tell you explicitly what's what? Let's say this is the end of the chapter. This is in the chapter review. They didn't tell you it was arithmetic. How do you know it's arithmetic? Yeah. I see over and over and over and over again that we're adding. So who's our common difference? And since we have a common difference, what formula can we use? The arithmetic formula for an nth term. So we'll use that formula to plug and chug, and what do we know? Yeah, 3 is our initial term. Don't know n, right? Common difference is 7. Wait, what are they asking us for? They don't say find the nth term formula. They don't say find the 20th or the 10th or the 5th term. Yeah. They're saying this sequence, dot, 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 keeps going until it hits this number.
when does it hit that number? A sub, yeah. So take 129 and say, he's an nth term, I want to know which n. I want to know when he's going to show up. So I can go ahead and plug in 129. Just trying to solve, right, cool kids? We can't distribute the 7, it's up to you. We could subtract the 3, divide the 7, whichever order you want to do. I kind of just see I want to get to this end, so I'm going to go ahead and subtract my 3. You guys okay if that show all the work, all the work? So I subtract 3, I get 126, I divide by 7. Mental mathers, what do we got? 18? Oh, 19, yeah. Duh. No, 18, because 56, 7 and 56. But hold on, 18 is not n. 18 is n minus 1.
Wait. What about the 7?
Sorry, I subtracted 3.
Oh.
I didn't show all my work. I apologize. There you go. Is that better? I subtracted the 3 and got 126, then I divided the 7 and got 18. Then I add 1, I get 19. So if we were to figure out how to put this formula in our graphing calculator, which we probably could, this would be our u of n. Remember in our sequence mode, it's u. This would be our u of n. We would plug and chug this guy. We go to our table, we could scroll down and say, oh, 29, when do you appear? And he would appear at the 19th, if we wanted to. All right, do you guys see how they might ask this question a little bit weird? They're still asking you to use the formula, just in a little bit different way. Okay. So that's still talking about sequences, sequences, sequences. Let's talk about, I just totally took away your notes. There we go. Oh, another tricky one? All right, one more tricky one. Trying to prepare you for the homework help. We're almost to series. They don't give us much in this one. Come on, my puzzlers, here's a puzzle. They give us the 4th term and the 7th term, and they tell us it's arithmetic. How on earth can we figure out the first?
I mean, it's in your formula, so you can send it.
We could do that. We could do like a little, we know we're using our a sub n formula. We could set up a little system of equations. We could say, well,
Well, that's 0.
we know who a sub 4 is. A sub 4 is 7, and that's going to be a sub 1 plus 4 minus 1 times a common difference, I don't know. A sub 7 is going to be negative 5, and that's going to come from a sub 1 plus 7 minus 1 times d. Could I solve this system of equations?
Hmm.
Yeah. Suppose I could. There is an easier way though.
Yeah.
For puzzlers. For those who just like formulas, this is probably the easiest because you don't really have to think creatively. You guys see how you could solve? Couldn't you do like elimination or substitution?
D is -4.
Yeah, if you use elimination, you would subtract the 2, you'd end up with something like, not negative. From Philistine, distribute that negative. 7 minus negative 5 would be 12. A1 minus A1 cancels out, and I have 3 minus 3D minus 60 would be negative 3D, right? So D is equal to negative 4. Which makes sense, it's negative. Isn't it going down somehow? That had to go down. But, for puzzlers, sorry, that's D, you would plug back in, plug and chug. 3 times negative 4, negative 12, negative 12, plus 7. A sub 1 ends up, after some quick substitution up above, to be, I think, 19. But for puzzlers, it might have been a little bit nicer for us to go ahead and say, well, wait a minute, hold on. We know a sub 4 is 7.
a sub 5, a sub 6, a sub 7 is negative 5. How many jumps would it take to get there of a common difference? 3. What is the difference between negative 5 and 7?
12.
Down 12, right? So we could say 3 common differences has to equal negative 12. From that, we could have said D is equal to negative 4. So that can actually fit that. And then how do we go back to a sub 1? Well, there's 3, there's 2, there's 1. How many jumps backwards are we going to make? 3. And we're going backwards, so instead of subtracting, we're going to be adding. So in order to make that jump, we're going to say 7 plus 3 times 4 is 12. Ends up to be 19. Now once again, is that a little bit creative? Yeah, technically. Do you have to do the jumpity jump jump pattern, puzzling, thinking out? No. Do the formulas work? And the answer is yes. Either way, first term 19. Okay. Those were all homework helps. But we do need to talk about one more special formula, and I'm just going to show it to you guys. Yeah. This is our last special formula for section 9.2. We've done the sequences, that's when they're separated by commas. What we haven't talked about are series, and this formula kind of comes from this guy named Gauss. That's from when he was in an elementary classroom. I think he was like second grade, I might be wrong. As the story goes, or maybe this is some dilution of the story, I apologize. As the story goes, there was one day that this particular class of elementary kids was particularly rambunctious. Poor teacher was tired. A little frustrated. Just had them, this was a long time ago, yes. On their, I think it was like chalk slates. Gauss isn't that old. Told them all to add the numbers from 1 to 100, hoping for some sort of peace in the midst of the storm. Sat down at her desk thinking she could at least breathe. She heard all the writing utensils working furiously. Yes, they had grit. However, little smart aleck Gauss came up with the answer on his board in a matter of moments. Teacher hadn't even figured out the problem yet. She was thinking she'd have at least a few minutes before she would need to. She thought he was just being a little smart aleck, and so she decided to check to see if he was right, prove him wrong, and have him keep working. But sadly, she figured out that he was right. How did he get 50-50 really quickly? Question, what's 100 plus 1? Question, what's 99 plus 2? What's 98 plus 3? What's 97 plus 4? Didn't have to do repeated addition, he just had to do 101 times 50. Which is the exact same thing as the S sub n formula for any arithmetic series where there is, what's the common difference of adding the numbers from 1 to 100? This is an arithmetic series where you have a sub 1 is 1, b is 1. Plug it in, plug it in. Alright, cool kids, we technically have a couple examples to go over tomorrow, but you should be able to do the majority of this homework. We'll quickly finish 9.2 and start 9.3. Bye guys. You wanna talk about it?
Oh, sorry.
Make sure you don't have to because this one you didn't but this, remember you go down.
Have a great day.
Thanks, you too, Caleb.